Hi guys, last week I was at ICML in Vancouver and there were so many different interesting projects and papers that I want to talk about in this video. I was also in the booth of Amazon as an applied scientist and I talked to so many of you guys. You can connect to me through the LinkedIn and I will be happy to chat. Welcome everyone to our channel, AI Fun Fact for All. For those of you who are new to this channel, my name is Pedram. I have a PhD in computer science, and this channel I talk about AI and machine learning and how we can use it in order to improve our efficiency. As I mentioned in this video, we are going to talk about some of the important papers that I saw and some of the interesting projects that I want to consider as a spotlight in this video. It's not going to be extensive. I put the link of extensive list in the description of the video. Make sure to check it out and then let me know in the comments if I've missed something or there was another project that you thought it was worth looking. On the first part of the video, I'm going to talk about a few of the talks and probably also a paper that I thought are basically relevant to agentic systems and also something that lots of people can actually get information from. The first one is fleet of agent, which basically they mentioned that single query methods are cheap, poor quality, and then multi query methods are high quality and expensive, but how we can provide a better result. So if you look at in here, they talk about that, for example, we have chain of thought, tree of thought, and lots of other, but they provide this fleet of LLM and they provide a method based on the particle filter that try to basically do resampling and also mutation on exploring completely independently and improve the efficiency, so kind of like 3 times better than complete full graph exploration. The other one is consistently preserving safety when fine-tuning LLM on diverse datasets. So we all know that when we fine-tune an LLM on a specific dataset, we will lose the safety or red teaming attempt. So in this paper, they actually talk about how we can handle that. So they specifically talk about that basically how we can consider some notion of the alignment data sets and make sure that our gradients are also aligned with the pre-computed training. So we have a specific safety data set and we will use that in order to use during our fine-tuning. Then I want to talk about this paper from Google DeepMind that talk about the general agent needs word model. In a nutshell, this paper actually proposed that an agent, in order to be able to generalize to the other tasks, it needs to learn a word model from the environment, and without that it's basically not possible. Then there was a talk about the quantization and its effects on the accuracy. They basically mentioned that the quantization has a relation to the perplexity linear to the relative layer-wise L2 quantization, or basically they showed that after 4-bit quantization, lossless quantization is basically pretty much impossible. There are so many papers about LLM as a judge. If you know that it's basically getting a lot of attention. So they talk about something like using LLM as an examiner. So we have like a peer review and then TA review, and we want to compare them together. One very obvious approach is that you provide the user prompt that read this and then compare, basically very systematically doing it in a very naive way, but the problem is that it obviously can get affected with the prompt injection, and also the performance that you get doesn't necessarily align on the different quantities or the different metrics that you want. So the idea that they mentioned that let's try to move from textual to numerical elicitation. So basically they divide the text into multiple components, and they said that is it poor, unknown, or good, and then they provide a proof. There was a paper about Fusion cerebral alignment, adapting reward and LLM policy to neural process. So the idea about the alignment is based on the Bradley Terry Lewis or BTL model, which basically based on the social science in 1950. But this one assumed that there is a homogeneity and the entire population actually follows the same reward model. But what if it is not? Same as this example, if one person and another person poses completely different opinion, then are we averaging out? Basically this approach average out, and then we cannot see basically what is the true intention of individual user. So what is important is that the preference should be based on each user, or basically kind of personalized. And for that reason they develop an approach that basically try to consider a latent variable which is user specific, and then the goal is that we try to find this reward such that given this reward learnable latent variable, it provides the maximum reward. In line with that, there was another interesting topic on personalization, which for RLHF, which basically it was for the NeurIPS last year, so I'm not gonna go over it into too much. I have created a video about the NeurIPS last year, so I put the link on that so you can check it out. But basically this one said that let's consider variational preference learning, which basically try to consider a statistical model for this Z variable, and then after you provide this Z model, the Z model will be conditioned to basically generate the reward function. Why is it important? Because it can also provide the paradigm for active learning, because you can then learn and measure the uncertainty over the Z and try to somehow maximize the information gain, because since it is a probabilistic model, if the uncertainty is too low about it, then you know that about this specific user you don't have that much information. So two line of work on this NeurIPS paper has been developed. The first one was basically, and they tried to use learning pluralistic user division through RLHF summary. So instead of having like a vector, fixed vector that was in their NeurIPS paper, they tried to say that, okay, let's consider some summaries. But how we can consider summaries, they call it plus, but basically how it will update it, they try to align it the output of the LLM with the actual result in the training. So there is a KL divergence, so it doesn't create gibberish result, but basically it try to encapsulate the important information about the user in a summary, and then it can provide the result. So basically we have some pi theta as a summary, and then it will create a summary in order to include it in our reward, and then the reward will be used to basically create the back propagation in order to maximize the policy. So the result actually pretty much promising in here. So the VPL is their NeurIPS paper. It provides a good result, but not very good on out of distribution. So you see OOD doesn't provide very good result, and then ICL or in context learning is basically you just pretty much dump all of the context inside, doesn't provide a good result. And then plus untrained is basically if you ask ChatGPT or any other LLMs to basically create that summary for you, again not as much as good, but this plus can actually provide a very good generalization task. And then the second line of work was that how we can actually use to create a curiosity reward that try to ask important question to improve the learning about a user. So they basically, the idea was that, okay, what kind of question we can ask that kind of maximize our information. So they consider 4 different LLMs in here, each of them like environment, policy, user model, and the reward model, and this will keep working together. There is a possibility of reward hacking. They also talk about that, but basically comparing SFT method. Basically, you have the agent in the RLHF. They see that they try to ask some question about, for example, what's your name and so on. So try to work with memorizing and see that, okay, so this name, then what I can offer for that. But in Curio, so their approach, they actually try to provide what is important for that specific realization of what is the most important concept for that. And then the reward hacking in here, that it will keep working in a way such that it kind of trick the LLM or the evaluator in here such that it will maximize the reward and try to provide the result on some cases that it has a very high certainty about, and kind of create some notion of mode collapse. On the second part of the video, now let's go over the flash round. I'm gonna list a number of standing papers that I think are important, and then I will talk about a few sentences of what make them different. You can basically search them online to find the exact paper. So let's start. In ICML, there were few position papers that provide an outstanding and new novel result. So some of them, I'm gonna very quickly go over them, such as AdaSplash. So it was an adaptive curriculum learning via soft sampling. So they proposed this, which dynamically adjusts the training samples to based on the gradient norm and loss. And then we have tests, which basically training with exploration sensitive sampling. So some idea from active learning. So tackle exploration in long horizon decision making task, and then prioritize transition using exploration sensitive score. And then we had instruct zero, so a multitask zero-shot agent with latent program inference, which introduces zero-shot agent trained with instruction and latent program alignments. It was capable of multitask generation without fine-tuning. B2C, back to context for a scalable in context RL. There were so many papers in RL in this video. I'm going to talk about one of them, particularly about the alignment, so make sure to watch until the end. We have like progress in context RL methods that demonstrate resetting to past states and improving sample efficiency for offline and online RL. Then we have like LM data evaluation via Shapley scores. So applies a Shapley value theorem to qualify the contribution of pre-trained data. And then we have Piglet, which was pre-training with grounded language and temporal goals. So introduce a pre-training method grounded in both language and temporal goals. There was Elysis, which is uncertainty aware curriculum for offline RL. Again, another curriculum learning inspired approach. So build a curriculum based on epistemic uncertainty estimation and improve exploration and policy learning in a static offline dataset. And a Magnify, which was a memory augmented graph neural network for long horizon reasoning. So combine graph neural network with memory modules to handle long-term dependency, and useful for physical reasoning and decision making tasks. Then we have Datacom, data competition for pre-training a robust vision model, and a new benchmark for evaluating. So there's always in these kind of conferences some benchmark that you can use. D3PM Gen, so diffusion models for a structure sequence generation. And there you have it, guys. We went over some of the important papers and talks in the ICML 2025 in Vancouver, and we discussed a little bit about them, and someone talked about a few papers that you can take a look. There is an extensive list of this position and most important papers based on my honest opinion that I put the link in the description, so please check it out. If you enjoyed the video, make sure to like it. More importantly, subscribe to the channel. If you want to see the video on the nerves, make sure to watch this video. If you are AI engineer and want to learn more about agents, you can watch my latest video in here that I talk about context engineering. Thanks for watching, and see you until the next one.